Good evening. Some of you asked me on my website, explainingmaths.com, to solve entire past papers. So that's what we're going to do now. We're going to do paper of May, June 2014, paper 21. And that's the first paper of the extended curriculum. And you have an hour and 90 or an hour and 30 minutes to complete it, which is 90 minutes. Just before we start, you make sure that you round correctly. So everything, if it's not specified and your answer is not exact, you give your answer correctly 3 significant figures or in degrees to 1 decimal place if you're talking about angles. Okay, you can get 70 points and you're allowed to use a calculator. Now let's get started. Again, before I start, I want to give all credits to Cambridge Examinations because it's their paper. We are just here simply to help each other to understand maths a bit better. So make sure to check my site explainingmaths.com if you have any further questions. So this is the first page, question 1. Use your calculator to work out the square root of 3 over 4 plus 2 to the power minus 1 and give your answer correct to 2 decimal places. Now this is for 2 points, so make sure you write down some workings. And of course it's important that you round it at the end to 2 decimal places. So this is an exercise to check out if you are able to use a calculator properly. So press the square root of 3 over 4 in your calculator and write down what that gives you. It gives you 0.86600254038 plus, and 2 to the power minus 1 is the same as 1 over 2. Your calculator will even tell you that. So if you plug it in your calculator, all of that, that will equal to 1.366025404. And I always suggest that you give the entire non-rounded answer first, after which you're going to round 2 decimal places. So 36, so the 6 becomes a 7 because of the next decimal, so 1.37. Fantastic. Moving on, we have some sort of equation or formula. Y equals 2 over x squared plus x squared over 2. Find the value of y when x is 6. Give your answer as a mixed number in simplest form. Okay, so we're going to substitute the value 6 for x. So y equals 2 over 6 squared plus 6 squared over 2. And as you can see, again, this is for 2 points. So you want to write down some workings. 6 squared, that's 36 plus 36 over 2. So that is actually, you can put it in your calculator if you don't know, plus 18, so it's a mixed number. 18, 1 over 18. So not a top-heavy fraction, no, a mixed number consisting out of a whole and a fraction. There we go, for 2 points. Last question on this page. Solve the equation n minus 8 over 2 equals 11. And what do you need to do to make n the subject? Well, first of all, we're going to get rid of that fraction. So I'm going to multiply both sides by 2. So I'm going to say n minus 8 equals 22. That's your first point. And then I'm going to add 8 to both sides. Or some say I'm going to move 8 to the other side. So the sign changes. 22 plus 8 and will be 30. There we go. Moving on to the next page. Oh, sorry, wrong arrow. Moving on. Yes, there we are. Fantastic. Already question 4. What's going on? I see some difficult looking formula there. Let's find out what it is. In the spaces provided, write each number in this calculation correct to 1 significant figure. Okay, so that's what we're going to do. 1 significant figure, so that's the first number, which is not a 0, so it's a 4. And then you round the same as with decimals, it becomes a 5. Or if it stays a 4, depending on the next number, which is an 8, so it becomes a 5. If it's a 5 or higher, you round up. 1 is the first significant figure, and that will also become a 2. And then the 16.8, so the first significant figure is a 1, and that will become a 2 because of the 6. But then you have to put that 0 there, 20 at a 0 place holder. Otherwise you're not. If you don't just write down a 2. Okay, 5 times 2 divided by 20. Use your answer to part A to estimate the value of p for 1 point. So that is 10 over 20. That is a half, 0.5, or 1 over 2. There we go. And then probably you have to put it in order. Yeah, also a very common question. Write the following in order of size, smallest first. Okay, so in ascending order, as you can see also looking at those inequality signs. And the best thing to do is to convert these values into decimals. 0.5 squared, let me write it down, is 0.25. That stays 0.5. And to the power of 3 is 0.125. And the cube root, let me just find it out what that is in my calculator. The cube root of 0.5 equals 0.7937. Okay, let me just put the 0.5 here, then I can order it easily and compare it. Now, what is important, when I write down the numbers, I have to use the original values. I'm just converting them into decimals so I can easier see which one is bigger, which one is smaller. I have to start with the smallest first. That is important. Okay, the smallest first. So what is the smallest? Well, they all start with a 0, so they're equal there. But then we have a 2, a 5, a 1, and a 7. So this one is the clear victory. It's the smallest. So 0.5 to the power of 3 is the smallest. Yeah, so I use the original number. I'm just going to put a little cross through it. That I can still read it, but that I know that I have done that one. Okay, moving on. So which is smallest then? We're still looking at the 2. So the tens. 2, 5, 7. So 0.25 is the smallest. So I'm going to write it down. Oh, I'll do it in black. 0.5 squared. And a little cross through this one. And then the 5 and the 7. So really 0. Now, why is it? Do I still keep forgetting it? 0.5. And then finally it's the cube root of 0.5. Yeah, so perhaps you would have expected that if you take the root of something, you're going to get a smaller number, but that's not the case because we're talking about a decimal 0.5. Okay, so convert them to decimals, then you can easily compare the 4 values and put them in the right order. Smallest first, and I've done that, and make sure you use the original number and not those decimals you found. Okay, question 6. Carlo, he changed 800 euros into dollars for his holiday, and the exchange rate was €1 is $1.50. But then his holiday got cancelled. Poor him. He changed all his dollars back into euros, and he received 750 euros. Find the new exchange rate. Yeah, so those rates, they change all of the time. Well, let me find out first of all how many dollars he got. Yeah, so he had 800 euros, and he got 150 for one. So 800 times 150, that's 1,200. Let me just write that down. So when he was going on holiday, he got $1,200. But then his holiday got cancelled, and he wants his euros back, and he got 750. So if I divide 1,200 by 750, and I'm going to check that in my calculator, 1,200 divided by 750 equals 8/5. And in money, that will be, what is that, 3/5, which would be $1 and 6/10.6, or do 2 decimals there for the cents, so $1.60. Okay, you can always check that if that makes sense. So I had 1,000. So it's basically do the inverse operation to make sure you get back to 800 euros. Okay, moving on to the next page. I'll see you there. So we're still solving an entire past paper, 2014, paper 21 of May, June. Because some of you have asked me to help on my website, explainingmaths.com. Question 7, we are at make x the subject of the formula. Now, there are several ways of doing this. Probably the best way of it is first, take away the 6 there. So it says x minus 4 squared equals y minus 6. And then I will square root both sides, okay? Because I want to get rid of that square there. I'm not going to expand it, because if I expand this, I'm going to get x squared minus 8x plus 16. So I'll have 2 terms in x. It's not going to work. Now I'm going to square root it. But before I square root it, I first have to put that 6 on the other side, or take away 6 on both sides. That's actually what you're doing. Anyway, square root it. So x minus 4 is the square root then of y minus 6. But that's plus or minus, okay? Because never forget that the square root of 16 is 4, but also a negative 4, because minus 4 times minus 4 is also 16, okay? So it's always plus or minus, so make sure you don't forget that. And then you to get rid of this minus 4, I plus it by 4, so I'm going to plus it by 4 on the other side as well, so plus 4 plus or minus the square root of y minus 6. Now make sure when you write that down that square root sign is very clearly around the entire y minus 6, or perhaps you want to put that in brackets just to make sure that it's clear to everybody. Okay, moving on. Write as a single fraction in simplest form. Now these are all worth a lot of points. 3 points there for the previous one, 3 points again. Single fraction, simplest form. Now if I want to add or subtract fractions, the denominator needs to be the same. And I explain this in a lot of detail in my videos. So I'm not going to do it now, but I'm just going to say that, the first fraction, I'm going to multiply that by the denominator of the second fraction. I'm going to multiply the second fraction by the denominator of the first fraction. So 2 times x plus 1 over x, but of course you will also multiply the denominator by it, because actually only timesing it by 1. Anyway, not too much information, otherwise I might confuse you. As long as you realize this fraction multiplied by x plus 1 and this fraction I multiplied by x, and this is what it's going to look like. And before I go any further, I'm just going to expand that first numerator. And you do not have to expand the denominator, because sometimes you can simplify by taking out a common factor. So do not do that yet. There we go. The denominators are the same, so now I can combine the fractions. So just going to start with my denominator x plus 1, and in the numerator it's going to say 2x minus 2x, so that's 0, and then 2 minus nothing minus 0 will be 2. Now make sure to check if there's a common factor. Can I get rid of something? No, I can't, so that is the final answer. Let's go to the next page. So question 9 already. A bus company in Dubai has the following operating times. So the day: Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and then starting time and finish time. And then it says calculate the total number of hours that the bus company operates in 1 week. And if I just scroll down a little bit, you'll see that's 3 points to count how many hours does it operate. Well, that's very kind of them. So we start at 6 in the morning, we finish at 12 at night, okay? So 6 in the morning till 12 at night, how many hours is that? Well, you have 12 hours to 6 in the evening. Then basically on your fingers you can count, so 6, 7, 8, and 9, 10, 11, 12. So that's another 6 hours. Or if you realize that 6 hours in the evening is 1800, then it's another, from 1800 to 2400, it's another 6 hours. Anyway, so in total that will be 18 hours. I'm just going to write down 18 hours. Now another way you could have found that is by minusing basically 2400, subtract 600. You're going to also get 18 hours. So on Sunday it's the same operating hours. So again 18 hours. You're going to put that there, and it's 18 hours here, and it's 18 hours there, 18 hours on Wednesday, 18 hours on Thursday. But on Friday they have a bit of not as long of a day. It's a Muslim country, so they are probably praying before 1 o'clock. So from 1 in the afternoon to 12 at night, well, that is 12 hours. It would be 1 o'clock in the night, so 1 hour back. So in total that will be 11 hours. Okay, now perhaps you want to write this down a little bit more simple format. So you could write down 1, 2, 3, 4, 5, 6. So 6 times 18 plus 11. And if you work that out correctly, you're going to get 119. So I'm just going to go down and put 119 in it. There you go. So several ways you can approach this. I basically do it on my fingers. I count it. You can subtract to get 18 hours. Again, just find the way you prefer to do it. Question B, write the starting time on Friday in the 12-hour clock. So it's 1 o'clock, 1300, that's 1 o'clock in the afternoon. So that would be 1 o'clock p.m. Yeah, so 1 in the afternoon, which is 1 p.m. Okay, next page. So finally, we're getting to questions about factoring. And the first question you ask yourself about factoring is there a common factor? If you look at all the terms, and those are 4 terms in this case, and there's not a common factor looking at all 4. And the second question is, can you factorize it by grouping? And yes, you can. You have 4 terms. So you're going to look at the first 2 terms, and what is the common factor there? Well, it's a. So you're going to take that common factor out. So you're going to get in those brackets x plus y. And you look at the second 2 terms. What is the common factor? And that is b. And then in those brackets, fingers crossed, but you should get the same as those brackets there, x plus y. And indeed, if you get b out, you'll have x plus y left. So my final answer will be x plus y times a and then times b. And again, I explain this in a lot of detail on my website explainingmaths.com. Now I do it just relatively quickly. Moving on to the next question. It looks slightly different than what you're used to perhaps, but you should realize that what does that mean? That square there, that means x minus 1 times itself. So perhaps you want to write it out like that. Okay, minus 1, come on, there we go, plus x minus 1. So what is the common factor? Because that's the first question you ask yourself when factoring. What is the common factor? Well, they both have an x minus 1. So let's take that one out. Put perhaps some square brackets, if that makes more sense to you. 3x minus 1 plus 1. There we go. So I took the x minus 1 term out, so this first part only has 1 left, and the second part, when it's out, you just have the 1 which is in front there, you don't see it, but the 1 left. Now that's not my final answer, because I have to simplify inside those brackets. What happens there, I'll continue here. So I have x minus 1, and then I expand those brackets, 3x minus 3 plus 1, there we go. So my final answer is x minus 1, and in the other brackets 3x minus 2. Yeah, the minus 2 coming from minus 3 plus 1. Fantastic. Question 11. Oh, not too far. A triangle has sides of 2, 8 and 9 centimeters. Calculate the value of the largest angle in this triangle. Okay. For 4 points, by the way, ladies and gentlemen, so that's a lot of points. Let me just quickly sketch a triangle, 2, 8, 9. It doesn't say anywhere that this is a right angle triangle, so do not just automatically sketch a right angle triangle. But I do see that, although it's only a sketch, but this is probably the largest angle. I could calculate all 3 of them. But I'm first, my gut's feeling says this is the largest angle, so we'll put a theta there. Now, how can I calculate angles in triangles? Well, what did I learn? Well, I learned trigonometry, sine, cosine, tangent, but I can only use that in right angle triangles, and I'm not sure if this is a right angle triangle. But then I can use the sine rule, but I need a full team, and I don't have a full team, so eventually I can use the cosine rule. Okay, and the cosine rule, what does it say? Yeah, and for 4 points, perhaps your instinct tells you already, oh, it's probably like a cosine rule or something. And it's a lot of points usually. The cosine rule, a squared equals b squared plus c squared minus 2bc cosine of a. And you need to realize that this lowercase a and the capital A, they're the teammates. They belong together. That's the angle and its opposite side. Now, considering we're looking for the angle, I am going to make the cosine of a the subject. So I'm just going to rearrange that. So I'll 2bc cosine a equals b squared plus c squared minus a squared. So what did I just do? I put this term on the left side, so it's positive. B squared plus c squared stays, minus a squared. And I'm going to divide by 2bc. So it's going to say the cosine of a equals b squared plus c squared minus a squared all of that divided by 2bc. Now, some of you remember this formula. I don't. I always rearrange it because I don't really like remembering things. Anyways, what is important, if I'm looking for a, theta, then I need to realize that this a, the lowercase a, is the length of 9. The b and c doesn't really matter, but I need to keep that in mind. So the cosine of, let's call it theta, equals b squared. Let's say that's 2 plus 8 squared minus 9 squared, and all of that divided by 2 times 2 times 8, times b times c. Okay, if you plug that in, let's find out what does that say. So that will be 4 plus 64 minus 81. So that numerator is going to say minus, it's going to say minus 13. There we go. And in the denominator, it's going to say 2 times 2 is 4 times 8, 32. But then to find the actual angle, you have to do the inverse. So shift, if you like, cross in your calculator. So shift cosine, the inverse of minus 13 divided by, is that an 82? Why do I write 82? Sorry guys, 32. That doesn't make sense, does it? 32 equals, and it tells me 113.969483. There you go. Always write down the entire answer, then I'll round. These are angles, so 1 decimal place. So the 9 goes actually to a 10 because of the 6. So it will be 114.0 degrees. Now, why do I know already that this is the largest angle in a triangle? Because a triangle can only have one obtuse angle. Because if a triangle would have 2 obtuse angles, then it wouldn't be a triangle. So if I have one obtuse angle and here another obtuse angle, it will never be a triangle. It's not possible, because the sum of the interior angles is 180. So you can only have one obtuse angle. So therefore, I already know this is the largest angle in this triangle. A cosine rule, and again for 4 points, that is what you would expect to be doing, cosine rule. Check my website explainingmaths.com where I explain the cosine rule in more detail. Okay, moving on. Question 12. P is 4 times 10 to the power 5 and Q is 5 times 10 to the power 4. Find, giving your answer in standard form, PQ, which basically means P, which is 4 times 10 to the power 5, times Q, 5 times 10 to the power 4. So plug it in your calculator and then make sure to write your final answer in standard form, which is 2 times 10 to the power 10. There we go. BQ divided by P. So make sure you do Q actually. So 5 times 10 to the power 4 divided by P. Do not swap them around. 10 to the power 5. Plug it in your calculator. Standard form is going to be 1.25 times 10 to the power minus 1. All right, question 13. I'll make this slightly smaller. There we go. Circle theorems, clearly, angles in circles, always very nice. Let's see what's going on. Before even reading, I have a quick look and analyze the situation. What do I see? I see the center, so that is a radius and that is a radius. So I always like to put those lines there. That reminds me of the fact that those lengths are equal. So this is a right angle triangle, not a right angle triangle, here let me, no, this is an isosceles triangle, okay? What else do I see? I see the arrow. The arrow, and I also see a cyclic quadrilateral. Okay, what do they say? They say ABCD lie on a circle, center O, and ABC is 58 degrees. Yeah, there we go. And CAD 23. CAD. Yeah, that's it. Calculate OCA for 2 points. OCA. So we're talking about this angle over here. So it's really nice that I put those lines there at the beginning because that is clearly a right angle triangle. So that angle, let's call it X, is going to be the same as this angle here. Let's call that X. So if I know this top angle, then I'll be able to find out what X is. But I don't know the angle here. However, I did tell myself, look at that, the arrow circle theorem. Okay, so what can I say about this angle? It is double the size of that angle at the circumference, and the angle in the middle is double the size of the angle at circumference. So 58 times 2, 116. Let me put it there in the diagram, 116. So what is x? That will be 180 minus 116, and then all of that divided by 2, and that is 32 degrees. Okay. Moving on, DCA, DCA, so we will continue in blue now. We're looking at this angle here, I'll call it Y. Okay, so the triangle here, there you go. I'm looking for Y, I know this one is 23, so if I know this angle at point D, then I'll be able to calculate the angle Y. The cyclic quadrilateral, I told myself at the beginning, they never give you information you're not using. It's clearly a cyclic quadrilateral, which means that the opposite angles add up to 180 degrees. So at point D, it's going to be 180 minus 58, which is 122 degrees. So if that one is 122, let's write it there for you, 122, then Y equals 180, and the sum of the interior angles of a triangle, minus 122 minus 23. And what is that? That is 35 degrees. There you go. Circle theorems. Check my website explainingmaths.com, where I explain those in a lot of detail. Okay, moving on to the next page. So we are doing well. We are now at question 14, and we're doing an entire past paper together, paper 21 May June 2014, if I remember correctly, because some of you asked me on my website Explaining Maths to help out. Let's find out. Question 14. Point A, 5, 10, and B, 13, minus 2 are 2 points on the line AB. The perpendicular bisector of the line AB has a gradient of 2 over 3. So perpendicular bisector means dividing the line AB in exactly 2 parts, and it's perpendicular, so a 90-degree angle over there. Okay, and this length from the point to A equals the length from that midpoint to B. That's perpendicular bisector. Has a gradient of 2 over 3 apparently, and indeed, as you can see, it's going up. Find the equation of the perpendicular bisector of AB. So we're finding the equation of the red line. Okay. If I scroll down, because it's the only question on this page, it's worth 4 points. So yeah, you're going to do some work for it. I'm just going to make it slightly smaller. There we go. So I have some space to work. So what am I going to start with? Well, let's just start with saying that the line of the equation of a line is y equals mx plus c. This is coordinate geometry, where m is the gradient and c is the y-intercept. Yeah, but we don't know the y-intercept now. But I do know the gradient, so I can already say, well, y, I'm talking about the perpendicular bisector, is 2 over 3x plus c. I do not see the y-intercept, but if I know a point on this line, I can evaluate the equation for that point and then calculate c. But I do not know a coordinate on this line. Yeah, but I do know that it goes exactly through the middle of the line AB. So I can somehow calculate this coordinate over there. So how can I do that? Well, that midpoint, what is the midpoint of AB? Well, the x-coordinate is going to be exactly between 5 and 13. Now, what lies exactly between 5 and 13? How do you calculate that? You do 5 plus 13 divided by 2. So it's 18 divided by 2, that's 9. 9, comma. I'm going to do the same for the y-coordinate. So 10 minus 2. So what lies exactly between 10 and minus 2? So you do the same thing. You're going to add them. So 10 plus minus 2 divided by 2, 8 divided by 2 is 4. So the midpoint, or the perpendicular bisector, goes through point 94. So if I evaluate, back in red, the equation for 94, then I can find the value of c times 9 over 1 plus c. So 4 equals, let's just work out that multiplication. When it's at 18 over 3, it's going to be 6 plus c. So c will be 4 minus 6, which is minus 2. So my final answer, I'll just scroll down a little bit and write it on the dotted line. There we go. So my final answer is going to be y equals 2 over 3x minus 2. There we go. Move on to the next page. So we're at question 15, where we have to solve the inequality. Let's just put it there. Solve the inequality for the positive integer values of x. Integers are whole numbers, positive or negative, yeah, but whole numbers. But now we're only looking at the positive integers. Okay, that's an interesting part of that question. Let's find out what are they doing. Okay, this inequality. Let's get rid of the fraction first. So we're going to multiply both sides by 5. So it will look like this. 21 plus x is bigger than 5x plus 5. Okay, and then we start isolating x. So I'm going to take away x here, and I'll take it away there. So my next step, it says 4x plus 5 equals 21. I'm going to take away the 5 on both sides. So it says 4x is smaller than 16. And then finally, I had to get rid of that coefficient 4. I have to divide both sides by 4. So it says x smaller than 4. And so try to read this as an Arabic person, from the right to the left. X is smaller than 4. Now I prefer to read from left to right. So I'm just going to turn that around, but really treat that inequality sign with respect. Okay, so I have to turn that inequality sign around as well. X smaller than 4. They tell me solve the inequality for all positive integer values of x. Well, it has to be smaller than 4. So what can x be? Well, x could be 3. It can be 2. It can also be 1. Yeah. Those are the integer, the whole numbers, smaller than 4. So do not include 4 in your answer, because that will be then x smaller or bigger to 4, or equal to 4. But it is not equal to 4, so do not put a 4 here. It's 3, 2, and 1. You could put a 0 there. They wouldn't take away points, I guess, but it's better that you don't. All right, moving on. Indices, clearly. And let's see what's going on. They say 2 to the power 24 to the power half equals p to the power 4. Find the value of p. Well, what can you do with those brackets? What do you have to do with those indices? You have to multiply them. So you could probably even do it in your calculator, probably, can't you? So 2 to the power 24 times a half, 12, equals p to the power 4. Well, there's several ways of doing this. Probably best is for you guys to work it out in your calculator. 4096 equals p to the power 4. And then you could try a few numbers, 5 to the power 4, it should equal that, or 6 or 7, and then you'll find very quickly that your answer is 8. So by trial and error, I always have difficulties pronouncing that, but then you can work it out that p needs to be 8. Moving on to the next, didn't mean to do that. Next question, x squared plus x squared over x to the power of quarter times x to the power quarter. Do I say x? Why do I say x? It's q. It's clearly q squared. Guys, it's getting late. I'm going to have to hurry up. Let's start with the numerator, 2q squared over, and then the denominator. When you're multiplying with the indices and the base is the same, then you add the indices. A quarter plus a quarter, so that is a half. There you go. And not finished yet, because if you're dividing the second law of the indices, what do you do with those indices? You subtract them. And please look at my website, where I explain all of this in a lot of detail. I'm just doing it fairly quickly now, but 2 minus a half will be a 1.5. So 2q to the power 1.5, or if you like, 3 over 2. So my website, explainingmaths.com. You'll find all you need to understand this a little bit better. Let's go to the next page. So obviously some sort of pie chart question here. Let's find out. The travel brochure has 72 holidays in 4 different countries. Okay, so Malaysia, Thailand, Hong Kong, Singapore, where clearly Hong Kong is the least popular destination, then Singapore, and I guess Thailand, followed by Malaysia, which is the most popular destination. I'm just going to highlight those 72 because that's important. Yeah, that's the total amount of holidays. Yeah, that's everything together, 72 holidays. The pie chart shows this information. Okay, good. They say there are 24 holidays in Thailand. All right, so always, put that in your diagram. 24 holidays over there. Show that the sector angle for Thailand is 120 degrees. So I have to show that this is 120 degrees. Okay, fantastic. How will I do that? Well, what I can do is I need to realize there's several ways of writing this down, but you can do it in like proportion, direct proportion. That 360 degrees, let me just put degrees there and holidays here. So how many holidays represent 360 degrees? So everything is 72 holidays. Okay, so the entire pie chart, 360 degrees, 72 holidays. Well, they told me in Thailand there are 24 holidays. So to go from 72 to 24, I have to divide by 3. Because 72 divided by 24 is 3, then I'll have to divide 360 also by 3. So 360 divided by 3, that is 120 degrees. Okay, and again, there are several ways of writing that up. You can do it like this with direct proportion. Okay, moving on to the second part of this question. Let's scroll down a little bit. I'll make it slightly smaller, so try to squeeze everything in one page. I hope you can still read it. They say the sector angle of Malaysia is 150 degrees. Yeah, we already knew that. The sector angle for Singapore is twice the sector angle for Hong Kong. So Singapore, this angle is twice the size of Hong Kong. So let me see, what can I say? Well, I can say if Hong Kong is, let's say, x, then Singapore will be twice the size, so 2x. And we already said at the beginning that Hong Kong is the least popular destination, so this one is actually twice as popular as Singapore. Okay. Calculate the number of holidays in Hong Kong. So how many people go to Hong Kong? All right. Okay, I'm going to write my workings here because I need this diagram and I don't want to be scrolling up and down all of the time. So in order to do that, I first want to find out how many people actually go to Malaysia. So I'm just going to put a line here. There's a reason why they give me this information here. I got to do something with it. So I'm going to find out how many people go to Malaysia, and then I'll know how many people are left to go to Hong Kong and Singapore. So 150 degrees. Well, there are several ways of writing this up. What am I going to do? I'm going to do 360 divided by 72. So the full pie chart divided by the full amount of holidays, and that is 5. So that means that each 5 degrees represent one holiday. And considering Malaysia has 150 degrees, I'm going to do 150 divided by 5, and that is 30. So apparently 30 people go to Malaysia. And I want to say again, there are different ways of writing this up. You choose whatever makes most sense to you, as long as you do it properly. Okay, so 30 people to Malaysia, 24 to Thailand. So 30 plus 24, that is 54 people already are going on a holiday out of the total amount of 72. So how many people are left? Minus 54, so that will be 18. So 18 people either go to Hong Kong or Singapore. Now, just going to go a little bit down. There we go. We said that that Singapore is twice as popular compared to Hong Kong. So 2x, the amount of people going to Singapore, plus x to Hong Kong, that must be 18. So 3x is 18, x is 18 divided by 3, which is 6. They're asking me calculate the number of holidays in Hong Kong, and that we said is the x, because they would ask me how many people go to Singapore. I'm interested in the 2x, but now just Hong Kong x, so the final answer is 6. Okay, we're almost there. We're going to the next page. I'll see you. Good. Question 18, a question about cones, and they're taking something away here. And if you want to know more about cones, please check my website, explainingmaths.com. I explain this all in a lot more detail. I'm now going fairly quickly. Good, let's find out what's going on. They say a solid cone has base radius of 4 and a height of 10 centimeters. A mathematically similar cone is removed from the top as shown in the diagram. So they're going to take that one away, and that is similar. Okay, so similar means corresponding angles are equal, corresponding sides are in proportion. The volume of the cone, that's important, the volume of the cone that is removed is 1/8 of the volume of the original cone. Okay. Explain why the cone that is removed has a radius of 2 and a height of 5. Okay. Now, what did you learn about similarity and... I'm just going to put that there. What did you learn about similarity and area and volume, for instance, and length? Well, for a length, you have a scale factor, and with length, you just times it or divide it by the scale factor. But for area, you have to do the scale factor squared, and for volume, you have to do the scale factor to the power 3. Now, I just want to decrease the size of the question slightly, so I have some space to write down my workings. So the volume, what they took away, is 1/8 of the original volume. Now, with similarity, what do I have to do? 1/8, then I have to do that. Take the cube root of that, because that is the scale factor to the power 3, the scale factor cubed, because we're talking about volume, and the cube root of 1/8 is 1/2. So the scale factor is actually 1/2, a half if you like. So therefore 4 times a half is 2. That's why it has a radius of 2, and 10 times a half is 5, and that's why that cone has a height of 5. So again, scale factor with volume and similar shapes, you have to, depending on the question, but you need to realize it's always the scale factor to the power 3, which they take. So if we work in the inverse direction, I have to take the cube root of that number, 1/8, to find the scale factor a half. Then if I look at the length, 4 times the scale factor, so the scale factor is a half, 4 times a half is 2, and 10 times a half is 5. Okay. Moving on, calculate the volume of the remaining solid. Okay, so we're interested in that part here, just that. So it's the original cone minus the cone they took away, and they even give you the equation, the formula to find the volume. Okay, so again, I'm going to make it slightly smaller. I hope you can still read it. What I'm going to do, I'm going to say V big, so that's of the big original cone. Again, there are several ways of doing this. 1/3 times pi times that one had a radius of 4 and a height of 10. And if I work that out, and I'll leave that in terms of pi, what is that? 16, 160 over 3. So that's 160 pi over 3. And I'm going to say V small, so that's of that small cone which they remove, which is 1/3 times pi that had a radius of 2 and a height of 5. So what is that? That is 420 over 3, 20 pi over 3. And again, I have to scroll down a little bit. I'm going to take that away from each other because we had a big cone and we took something away. So we have 140 pi over 3 left. I'm just going to plug that in my calculator. Was there a particular accuracy defined? No, so we will do it in 3 significant figures. So 140 times pi equals divided by 3 equals SD. Then my calculator says, I'll write it down here, equals 146.607657. So to 3 significant figures, that will be 147 centimeter cube. There you go. I think we're up to the last page. I'll see you there. So we arrived to the last question of this maths exam, and before I start, I just want to scroll down and show you this question is worth 7 points. Okay, so that doesn't mean it's a difficult question, but it means there is some work involved. Okay, let's find out what's going on. They say the diagram shows a rectangle ABCE. ABCE, that's correct, and D lies on EC. Okay, it's a point on that line. DAB is a sector of a circle with radius 8, and the sector angle is 30. Okay, so indeed that is a part of the area of a circle, a pizza slice if you like. What is the question? Calculate the area of the shaded region. Okay, and usually with questions like when you have to find the area of the shaded region, you have to find a larger area and then take some parts away. And that's what you have to do now as well. Because there's not a formula to find area of a figure of this particular shape. But what can I do? If I find the total area, so the area of the rectangle, there we go, because we all know the formula for that. And then if I take away this triangle, and if I take away the area of this sector, then I'll be left with the area of the shaded part, okay? And those 7 points are not just there for your final answer. Those 7 points, you earn them while you're getting to the final answer. So do not get discouraged thinking it's too difficult. Just start writing things down. Okay, let's start with the total area. So it's the rectangle, so length times width, 8 times. And then you notice you do not know this length. So does that mean you're unable to do it? No, of course not. Let me just draw this triangle. There we go. Separately. So this is AE. This is 90. This is 60 degrees. And this is D. Okay, so I'm looking at the triangle here. There we go. And the hypotenuse of this triangle, the length across the 90-degree angle, is 8 centimeters. Okay, now I'm interested to find out what x is. All right, so you can write down at the top so ka toa, or whatever your teacher taught you to write down. And in my angle I stand and I have the adjacent and the hypotenuse, so I'm looking at the cosine. So the cosine of 60 degrees equals the adjacent over the hypotenuse, so x is 8 times the cosine of 60 degrees, which is 4. Okay, so let me put a 4 there. Fantastic. So I can now calculate the area of the total rectangle. So the area of the rectangle is 8 times 4, which is 32. Yeah, so 8 times 4, that's that length, which is 32. So now if I get rid of, if I find the area of the triangle and the area of the sector and subtract them from 32, I'll have the blue area. Fantastic. Let's start with the triangle. The area of the triangle is half times base times height, where the base and the height make the angle of 90 degrees. So if I look at the triangle, these two lines make the angle of 90 degrees. 4 times, but I do not know this length. So what am I going to do? I can, by the way, calculate this length with a tangent or with a sine, but you also know another formula to find the area of any triangle, which is half AB sine C. Remember that? So I'm just going to take that B away, half AB sine C. So half times 4 times 8 times the sine of 60 degrees. Okay, and that is, I'm just going to plug it in. So my calculator, 0.5 times 4 times 8 times sine of 60 equals, it tells me 8 square root of 3. Okay, I'm just going to leave it like that. I don't like all those decimals yet. I'm going to put a little line here. There we go. Now the sector area. If I scroll down slightly, okay, there we go. So the area of the sector. How do you find that? Well, you always do the sector angle over 360. Yeah, that's the fraction, the part of the circle you're interested in. 30 out of 360 degrees. And what is the area of a circle in general? Pi r squared. So pi 8 squared in this case. And I'm going to plug that in my calculator. So 64 times pi equals times 30 equals divided by 360. And my calculator says 16 pi over 3. So my final step now is to do 32 minus 8. And I want to write that down, by the way. So again, I'm going down. There we go. So my final step is 32 minus 8 square root of 3 minus 16 pi over 3 equals, so 32 minus, what is that, 8 square root of 3 minus 16 sorry, I have to put it in my calculator properly. 16 pi, there we go, divided by 3 equals, and then my calculator tells me 1.3884372. So that to 3 significant figures will be 1, 2, 3. So the 8 goes to a 9, scrolling down. So 1.39 centimeters squared. Well, guys, I hope that was useful. Like and share if it was, and check my website explainingmaths.com, where you'll find all my resources for free. Have a good evening. Bye bye.